That's cool.
Hello. Okay. Hello. Hello. I don't think it's echoing. And now that's on there. So, y'all focus in. Do y'all remember direct variation? It's like from chapter 1.
Yes.
Yes? Okay. In direct variation, here's our formula. Y equals K times X. What is K? The constant of variation. It's right there. K is the constant of variation. In direct variation, what happens to Y as X increases? It actually, direct means they do the same thing. So as X increases, Y increases as well. Okay, so as X increases, Y increases. As X decreases, what do you think Y is going to do? Yes, they both go down. Okay, so when we have direct variation, this is the form that it goes in. When we're trying to find K, we just get K by itself, so we're going to divide both sides by X right here. So we get K equals Y divided by X. Those are the two kind of formulas that we stick to when we're trying to work with direct variation. Remember, the direct variation, whatever X does, Y does the same thing. For inverse variation, as X increases, what do you think Y does? Decreases. Remember, the inverse is kind of like the opposite. Okay, so as X goes up, Y goes down. As X goes down, Y goes up. All right, the main formula that we're going to use, especially when we're writing equations of inverse variation, we're going to use this Y equals K divided by X. Notice, when it's inverse, the X is on the bottom. When it's direct, the X is on the top. When it's inverse, X is on the bottom. Okay, so if it's on the bottom, it's probably inverse. And here is the K by itself formula for inverse. K equals Y times X. X times Y. We're going to write some equations for inverse variation. It says, suppose X and Y vary inversely. Okay, so inversely is key. It's telling you what kind of relationship they have. And X equals 3 when Y equals -5. So it just gave us a point, 3, -5, that's on this graph. Write the function that models the inverse variation. So our equation for inverse variation is Y equals what? K over X. And we are going to just finish out this formula by figuring out what K is. So we don't know K. We need to figure it out. What's the formula for K when we're doing inverse variation? X times Y? X times Y. So we just plug in. What is X for us? It's 3. Y is -5. Multiply them. We get -15. So we just plug that back into the formula right here. So we get Y equals -15 over X. And that's the answer. Ta-da. All right, see if you can do the next one on your own. Same thing, just different numbers. All right, what did you get? What's your equation? 0.42 over X? Yay, good job. Okay, you got that by multiplying, figuring out K, multiply X and Y together. Get 0.42. Any questions? All right, these next ones, let me read it. Is the relationship between the variables in each table a direct variation, an inverse variation, or neither? So we are going to look at each of these. So we'll look at this and figure out what kind of variation it has, if it has one. And then if it does, we're going to write the function to model it. We're going to start out by kind of figuring out what the relationship between x and y is. What is x doing as we move right to left? It's increasing. And what is y doing? Increasing. So what possible kind of variation do we have? Direct. Okay, I'm going to put direct with a question mark because we haven't confirmed it yet. All right, for direct, what does k equal? What's the little formula for k? Y over x. All right, we're going to use this formula and figure out k for each of these points. And if all the k's equal, then this is, in fact, a direct variation. So what is 0.15 divided by 0.5? 3. It is 3. What is 6 divided by 2? And 18 divided by 6? 3. So they're all the same, right? So yes, this is direct. And now we have to write a function for it. The formula for direct is y equals k times x. Got that from up above. All we have to do is plug in for k. Well, what does k equal? 3. We figured that out. So y equals 3x. There's your answer.
See, this makes sense. When it's 3x, the other thing above, I'm not really sure why it just makes no sense to me. Because it's over x, I guess. When it's inverse
Yeah.
instead of with x.
I don't know I don't really know what your question is or how to answer it. Let's do another one, see if it makes sense. Okay, so the next one, what happens to x as we go along? Goes up, and y goes. So what might we have here? Inverse. What? Okay, inverse. All right, Kyla says that it's, what does k equal? X times y. So what's 0.2 times 12? 2.4. What's 0.6 times 4? 2.4. And 1.2 times 2? So, this is inverse. And let's see, our equation for inverse is y equals k over x. So, what do we get? Y equals 2.4 over x. Just plug in the k that we got. All right, last one. What happens with x? And y? All right, so we have a possibility of, and k equals xy. So what's 1 times 2? 2 times 1. And 3 times 0.5. 1.5. So is this a variation? No. So your answer is neither. Or no variation. All right. For this next part, I'm actually going to skip the little first paragraph. It says, it is possible for 3 or more variables to be related. So all we were dealing with on the front was x and y. Now we're going to throw in a z and maybe a w and who knows what else. When we do that, so when we have more than 2, it's called a combined variation, or we're combining the variations. Okay, so when you have more than 2 variables, it's a combined variation. Here, for example, a variable z can vary directly with both x and y. All right, when they are both direct, that gets a special name that your book likes to use. And that's called a joint variation. So that's what goes in the blank there, a joint variation. Joint is specific for when they're both direct. You cannot use that when they're both inverse. They have to be both direct. All right, the equation for this would look like this. Z equals K, because we have to have our constant of variation, times X times Y. If they're direct, then the X and Y are going to be on the same level as Z. If they're inverse, like when we come down here, we have jointly with X and Y, so they're on top, and inversely with W, W is on bottom. So if it's direct, they're on the same level. If it's inverse, it's on the bottom of the fraction. Does that make sense? All right. If I say jointly, does that mean direct or inverse?
Direct.
Direct. So this one means direct. This one means direct. And this one was actually only supposed to say direct. All right, so these are just examples. So jointly with X and Y means X and Y is on top. Jointly with X and Y, so they're on top again. Inversely with W, it's on bottom. Direct with X, so direct is on top, or X is on top. And inversely with W and Y, they're on bottom. Now, just for help maybe, when it says blank varies, so like Z varies, or Y varies, or G varies, that's what the blank equal sign is. So you'd say Z equals, or Y equals, or G equals. If it says Anthony varies, then it's Anthony equals. Got it? Yes? Okay. So we're going to practice writing sentences like this in these problems. All right, it says Newton's law of universal gravitation is modeled by the formula blah, 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 blah. Here's your formula. F equals G times M1 times M2 divided by D squared. And it tells us that F is the gravitational force between two objects with masses M1 and M2, and D is the distance between the objects. Okay, we don't know what G is. Oh wait, here it says G is the gravitational constant. Constant is important here. G is the constant. In all of our formulas, what has been the constant? What's the letter that we've used for the constant? K. Okay, so just make note in your head here that G is like the K. When we described up here, we didn't say anything about the constant. So we don't need to say anything about the G, but we have to say something about everything else. So I'm going to start it off like it did up here. It says Z varies. So instead of Z, what will I have? F. So I'm going to say F varies. All right. How does F vary with M1 and M2? Directly. Or you could say jointly if you wanted to. Directly with M1 and M2. And then you can write it as one sentence or two. And then I'll say F varies. How with D squared? Yes, inversely. With D squared. After you identify your constants, that's the one you don't talk about. Whatever's on top is direct, whatever's on bottom is inverse. All right, let's go to the next one where they give us the sentence and we have to write the equation. So the volume V, okay, it gave me a variable, of a tetrahedron varies jointly, that seems important, with its altitude h, another variable, and base area b. Okay, jointly means direct or inverse? Direct. So are h and b going to be on the top or the bottom?
H and B are gonna be on top.
B, yeah. So they'll be on top. What do I have on the other side of my equal sign?
B.
V, and then what do I still need in there that's in all of these equations? The constant, yes, the K. That is where I feel like y'all are gonna get caught up, is that you're gonna forget to put the K in there. So make sure anytime you're writing an equation for a variation, it has to have the K. All right? Now it says the tetrahedron, or there's a tetrahedron with a 5 centimeter altitude. So what can we plug 5 in for?
H.
So H equals 5. 6-inch base, so 6 is
B.
B, and a volume of 10 centimeters. And we have to write a formula that models this joint variation. We have our formula, except that we need to figure out what the constant is. We need to replace that K. So we have to plug it in here, plug everything in, and solve for K. So we'll have that 10 equals K times 5 times 6. So that's 10 equals K times 30. Trying to get K by itself, so I will divide both sides by 30. So what does K equal when you reduce it? 0.3, so that's 1/3. All right, your final answer, all you have to do is write your formula with the K in there. So V equals 1/3 HB. Ooh, I thought of something I need to tell y'all. On your last problems on your homework, do not forget to put K in the equations, okay? Let me give you some hints for the ones like example 4. They're not going to give you this long drawn out paragraph. They're just going to give you a formula. Like, for example, A equals pi r squared. Remember, your first step is to identify the constant. So in that formula, what is constant? Like it can't change. Pi. All right, so pi will be your K. You don't have to talk about that. Another one might be like D equals 2R. What in that is set, it doesn't change. 2. Okay, you get the point? All right, so if there's a number or pi or something, that's going to be your constant. It's not going to come out and tell you exactly what the constant is. You have to figure it out.